Let's talk about factoring polynomials. We all know how to factor quadratics, or at least we should at this point. But what about 2x cubed minus 5x squared minus 4x plus 3? We don't have an easy strategy for factoring a cubic. So there's a couple of things that we can do that makes life easy. And the first question we have to ask ourselves is, whole number factors. Are there any? Well, the only possibilities are 1, -1, 3, -3. How do I know that? Well, when I multiply all the constant terms in a factored form of a polynomial, it has to end up being 3. And those are the only factors of 3 right there. So let's test and see whether or not any of these are factors. And what I discover immediately is that f of 1 is not 0, therefore not a factor. But I discover that f of -1 is 0, which means that not only is -1 a whole number factor, it means that x plus 1 is a factor of this polynomial. So that helps, because what this means is that I can write this cubic as a quadratic times x plus 1. And I now have the following. Well, how does that help me? Well, what if I divide both sides by x plus 1? I would know the quadratic. How do I divide both sides by x plus 1? I'm going to show you two quick strategies, and the first is using a geometric or generic rectangle. We know that x plus 1 times the quadratic is equal to the cubic. We also know that the cubic has a 2x cubed as its highest term, but that means that we know, make myself some room here, that my quadratic must start with 2x squared. Now that means that there's a 2x squared here just based on the properties of a generic rectangle, but I know that my quadratic has -5x squareds, and I have positive 2x squareds, which means that I must have -7x squareds in my rectangle in order to make this a total of -5. Oh, but that means that there must be a -7x in my quadratic, which means that this must be -7x. Okay, so far so good. But I know that my original quadratic had a -4x, and right now my rectangle has a -7x, which means I need plus 3 more x's to make a total of -4. But that means that this must be plus 3, and 3 times 1 is 3. And since my cubic ends in a plus 3, I now have the correct factorization. If it ended in something other than 3, I would have a remainder, but I don't have a remainder, so I'm set. Which means that I can write 2x cubed minus 5x squared minus 4x plus 3 as x plus 1 times 2x squared minus 7x plus 3. And of course, I know how to factor a quadratic, so I can finish the factorization of this polynomial, assuming that it does. In this case, in fact, it does, because I started with one that had three complete factors. So that's geometric rectangle. Another way is to just use long division. If you're familiar with long division, I'm dividing x plus 1 into 2x cubed minus 5x squared minus 4x plus 3. And looking at this, I know that I'm just dealing with the first term here. I'm not interested in anything other than the first term, except as a step towards the next line. I know that this has to be 2x squared. I multiply to get 2x squared, cubed, plus 2x squared. I subtract, this assuming you're familiar with long division. I don't know what they teach at the elementary schools anymore. I get negative 7x squared. I bring down the negative 4x. I know that I need a negative 7x right here. Multiplying this becomes negative 7x squared minus 7x. I subtract, and I get 3x, which means that I need a plus 3 right here. I bring down the 3, and multiplying x plus 1 by 3x, I get 3x plus 3. I subtract, I get 0. I am done with my multiplication. And notice that my quadratics are the same either way. Whichever way is preferable to you. I'm partial to the rectangle because I just think it's sort of cool. So, factoring, again, just to remind you of the steps, what is important here. Do you have any whole number factors? You can check them by making a list and plugging them in. And then if you do, turn the factor into a linear factor and then divide your original polynomial to get a polynomial of 1 less power. And you can just keep repeating the process over and over again until you run out of factors, or you have a quadratic, which you can just factor easily using other methods. So that is factoring polynomials. I hope you learned something.